Good morning, everyone, and welcome to this live edition of Ask Kyle for apt training. Today, we've got some amazing questions to go through on the subject of hydraulics and helping you guys become the fluid power experts on site, or even better yet, if you're feeling a little stumped, you've got a team and you're stuck and you're like, who has the answer? We've got Kyle and the team available for you to be your experts on the end of the phone or on site. Kyle.
Good morning, everyone. How cool is this?
So cool. So cool. So, sorry, guys. I'm Jay Green. I am the swimsuit CEO for APT, and I'm here to support Kyle today and facilitate all of your questions so that Kyle can make you guys look like superstars in your team. So, Kyle, can you just give me just a really quick overview for those that maybe haven't had as much exposure to APT? Who is APT and what do you guys do before I hit you with all the questions?
Big questions today too, already coming in. So it's been pretty cool to look at some of those. Looking forward to sharing a little bit of that. So APT, we do hydraulics training. We specialise in everything fluid power. You can see in the background there, I've got a student and Hayden doing some practical exercises. So they're having a ball out there playing with our excavator, going up and down. So our courses at the moment, this student's doing a blended course. So he does the training, the theory content online, and then he comes in here and works at his own pace, working through the practical exercises. Sometimes we've just got one student in here. Sometimes we've got more than one student in here, and this whole workshop can be fairly full. They're a fair way away from me at the moment. They're about 10 metres behind me, even if it doesn't look like it. So they shouldn't get in my way, and I shouldn't get in theirs at the moment, which is great. So we do everything fluid power, whether it be online courses, whether we do design work, and that's probably a little bit about where our questions come today is those specialised design questions. So yeah, we can sort of specialise in just fluid power. We don't worry about training in the basic stuff. We really specialise in just hydraulics and pneumatics.
Awesome. And I know that today we've had some really good questions on the back of last week's live, just going that little bit deeper and especially helping those people that are putting together designs and don't want to make a mistake that could cost them either downtime, money, or safety.
Very much so.
Get started?
Definitely. Let's rock and roll.
Okay, cool. My first question is from Steve. Steve asks, throttle check valve not controlling the speed of a motor. Previous to this, the issue had been it was overheating the system. Any suggestions?
So this is surprisingly a fairly common one, and Steve did actually allude to what the problem was, so I've got a bit of a hint on that one. But essentially, the overheating problem is a really common problem in a hydraulic system. Someone adjusts a valve incorrectly, something's not quite working properly, a cooler's full and blocked, or any of those sorts of problems. And so then what happens is the system overheats. And that's a relatively easy fix. We find what valve was incorrectly set, or we find the cooler that's full of dust and dirt, or we find a hose that's blocked, or whatever it is. So that side of it's relatively easy, and it lulls us into this false sense of security where we've solved that problem, the system's working now, we're all off and going. And then progressively over the coming sort of days or weeks, more and more problems come up. So all of a sudden, valves stop working, things start sticking, and it can be again that we've had some incorrect adjustments, but often what it can be is the seals in the system have overheated as well, and they've degraded, and then all of a sudden we end up with these pieces of O-ring and rubber floating through our system, jamming up all other valves. So Steve sort of said to me, in this particular case, what had happened is they pulled that throttle valve apart, and the check valve was jammed open by a piece of O-ring, most likely due to the overheating of the system. But it could also have been, he'd said there was a problem with the pump, and the pump had put a whole heap of shrapnel through the system, or bad stuff. And so they've fixed all of that sort of stuff. So there's a couple of things that can cause it. Really common problem. There's really tight tolerances in our fluid power systems. So for that stuff to happen, it happens really quick, and as I say, it sort of sneaks up on us a little bit.
Beautiful. So what's the key thing they need to do to prevent that?
Good maintenance is really the best tip. So looking after the system, making sure that if you're going to adjust things, that you understand what you're doing, what's happening, and that you're adjusting it correctly. Now, sometimes our procedures are incorrect and we get that wrong. So, you know, it happens inadvertently sometimes, but it's important to understand exactly what you're doing when you're making any adjustments. If you don't know what you're doing, probably a good reason not to actually dive in and do it. The second one is having good maintenance practices. And yeah, that can be as simple as having a regular routine of checking oil levels and checking all other things. Apologies for my camera dropping out there. So it could just be checking the oil level, for example, because if our oil level's too low, then the system will overheat fairly quickly. It can be cleaning out the cooler. You know, the cooler's sitting there trying to cool the system down, but if it's a dusty environment and that cooler's clogged full of dust, again, it won't cool and the system will overheat. So they're quick and simple things that can lead to overheating in the system. It's also good to check some basic system settings as well. And you know, to a tradie on the ground, they might look at these things and go, I don't really understand why I need to check this. You know, it's the same thing every time. You know, I check the oil temperature and it's always 45 degrees. Or I check the normal system pressure and it's always 110 bar. The reason that we want to check those things is that it can give us a trend. If we look and record that stuff, then we get a trend. And when we have a trend, we can then see when things start to drop or start to increase, and we know that we have to do something about it. So it's really, really good to maintain the system and record some of those things.
Beautiful. Do you work with organizations and engineering managers to help them set up those sort of routines and the operational side of things?
Yeah, this is a real common thing that we work on, where we, particularly for old equipment, you know, there's so much legacy equipment that's sitting in our industry. There's, you know, there's old machines, there's old equipment, there's old mobile equipment, and often either the information's been lost or maybe it never existed. So often we'll work with teams, maintenance managers or supervisors to help develop those maintenance strategies, and then the maintenance plan that sits underneath the strategy itself, so that everything can be looked after and hopefully give it a long-term thing. Sometimes that means that we've got to audit the system because drawings aren't right. We don't have schematics, and that's often the case. We've got this old machine and we don't have a schematic for it. So we need someone to help us get the schematic drawn and then help us develop the maintenance procedures behind it.
I'm sure that would save people a lot of time and money, though, without having those systems go down or ultimately ending up in a failure if something gets completely clogged, right?
Absolutely. Like, you know, trying to troubleshoot a hydraulic system without the actual schematic itself is like trying to drive somewhere without a map. You know, you really are just guessing what's going on. So, you know, from that point of view, it can save hours just being able to walk up, have a map and know exactly what you can do. And then if the maintenance is actually sitting behind that, that'll save heaps of time as well. But probably more importantly is by drawing the schematic and having a proper schematic there, we can set up the safety side of things, such as our isolation procedures, and we understand where there might be trapped or stored energy in the system. And this can be really, really scary and dangerous for our tradies. You know, we send them in blind without any information, and all of a sudden they're sort of caught out by, you know, a squirt of oil or something moving because they didn't actually understand what was in the system to protect them. So, you know, from a safety point of view, you know, it worries me some days to see some of these systems that have absolutely no data. But certainly if I was looking after a system on site, I'd want my teams to have all that information so that they can be safe too.
I actually heard a horror story. I meant to tell you about this the other day, Kyle, of someone that was working on the Thames River in England, and they were doing underwater diving and repairs, and they had some excavation equipment. Something had gone wrong with one of the pieces of equipment, and all the temperature gauges said it was fine. And so the guy, a good Irish lad, thought he'd just open it up, and all of the oil went all over his face and full burnt him. Like,
it's a scary story, and you know, like a normal operating system temperature might be around the 50 degrees, and that's a relatively safe temperature, but that still burns for a person. Yeah, that's a couple of minutes at that temperature, and we're still in a bit of danger. If a system's having problems and it's operating at 90 degrees, yeah, we've got maybe 3 seconds before we've got third-degree burns or full thickness burns. Now
It was so bad they had to have his head in a barrel and make him get one of the pipes to make a snorkel because he couldn't bring his face out while the ambulance arrived.
Yeah, and that's a really scary thing to think about. The recovery for that, the amount of rehab that he would be going through to recover from that is just really scary. And, you know, unfortunately in our industry, this actually happens on a regular basis. So that's a bit of a problem in itself.
Yeah. Oh, okay, let's move on from that. It's creeping me out already. I actually didn't catch the name of the person who sent this question through, but he asked, or she asked, in an open centered system, does the oil just flow to the tank when nothing is operating?
So this is a pretty cool question, this one. Now, we talked about a closed loop system last week and an open loop system last week. And so this is slightly different, where we're still talking about using directional valves to control where the oil's going. But we've now got an open centered or a closed centered system. So absolutely correct in the assumption that in an open centered system, the oil flows directly to the tank while we're not using it to operate a function. I did prepare for this question. I've got here a valve bank. So this is one that we use in our training. This is called a monoblock. The reason it's called a monoblock is there's just one chunk of steel here that everything's lobbed inside of. And they can be, this is a 2-function one, they can be 4s, they can be single. Now, in this particular one, this is an open-centered valve. What happens here is we connect our supply on the side, and this is our connection here. And basically all that happens is when we're not pushing or pulling the handles, the oil flows all the way through the middle, back to tank at no pressure and no load to the pump itself. When we pull the handle, it'll direct it to one of these ports and make the system work. There's a few different reasons about why we would use an open-centered versus closed-centered, and probably it's a bit of a misconception that it's related to what pump is being used. So a fixed displacement pump versus a variable displacement. We can use either arrangement with either system, so that's a bit of a trap, and you know, probably a misconception that can be pushed around a little bit. For this basic system, it might be that we've got it on a fixed displacement pump and we don't want that pump at high pressure and therefore a high power load and a high heat load while the system's not doing anything. So we push the oil back to tank, and often what we'll do is we'll put that oil through a cooler to cool the oil down as well. So we sort of get the benefit of no load while there's nothing happening, and we can use it to cool the oil down, ready for the next function or sequence to happen.
Amazing. And so when designing a system, like who's the expert that figures out which system to use, if you can use both, or how do you make those decisions, or how does someone get the skills to be able to pick what's the right thing?
This is really, really tricky too, trying to work out what to do and how to design the system. And you know, it can look really, really easy to go, you just draw a couple of things and hook them up and it'll all work. But you know, the heat load side of things, it can be really, really complicated. I know last week I talked about the explosives manufacturing truck that we designed. You know, the heat load calculations and the detail we had to go into to make sure that system was going to be okay was just phenomenal. We had a very, very small amount of oil, so we didn't have a lot of oil that we could heat up to start with. So the heat that we could actually put into it had to be reduced, you know, absolute minimum. And, you know, I'd say we probably spent, you know, 40 or 50 hours just on calculations around what heat load we were expecting to see in the system. Mm. The other thing that we often use is we'll use simulation software. We use a good simulation package for fluid power systems. It's only for fluid power systems, either hydraulics or pneumatics. And in that system, we can put in ambient air temperatures and the expected temperature coefficients of, you know, heat dissipation on each individual component, and get to a relatively accurate heat load on the system and how, you know, temperature rise and temperature cooling and all of those sorts of things. So, you know, it seems really, really easy, and in some simple systems, it is pretty easy to just sort of go, you know, guess and, you know, rule of thumb kind of stuff. But, you know, once you start to get to really, really tight systems with small oil capacities and, you know, high power loads, it's really important to actually put the time into it and analyse it properly. something we teach in some of our courses. So our diploma courses and that design level course, we talk about heat load on a system and the introduction to it. But often you also just need to refer to some people that are experts in it. So it might be the cooling manufacturers, or it might be the people that are supplying your equipment to you.
Yeah. Is that something you guys could do though? If someone got really stuck, could they?
Yep.
The Ghostbusters of fluid power.
The Ghostbusters of fluid power. We've used that a couple of times now, haven't we? So yes, we definitely can.
We need a new logo.
And a new logo. And I want the gun. So we do that sort of stuff. It's a common thing that we get called to look at is what's going on in this system. How do we deal with it, and how can we sort of reduce the heat load?
Gun for me.
Turn it into a gun, a Ghostbusters gun.
My gun instead of just rather than just my hose.
That sounds really good.
It'll be way more fun.
Absolutely.
Awesome. Okay, so what we'll do is, if anyone is like, holy crap, I need someone to audit my system, we're trying to do this design, we're tearing our hair out, crap, we could really do with some simulation software to make sure we don't make things go boom when they're not meant to.
Definitely.
We'll get the guys to, I think we've got someone online that can drop a link into the chat, and we'll make sure it's in the comments of any of the replays of the video that you can reach out and book a call. APT is Kyle's offering a free design review for anyone who needs to, have an eyes over it, wants a second opinion, doesn't know where there's a problem. You can jump on that link. Thank you, Isaac, for booking a call, and the guys will do a quick review for you. Or if you know that you're like just completely stumped on something, you're like, shit, help me, you can use that as well.
Yep. Just get in touch with us. We'll have a quick look through it. We'll give you some ideas on where you got to look, and where you might need to sort of get a bit more detailed in it.
Yeah, beautiful. Okay, beautiful. I think that when we were talking the other day, we were talking about how you've got clients that then have clients, and some of those are like equipment parts, like OEMs or people that are supplying, and they've got a team that's supposed to be able to troubleshoot, but then they don't actually have the experts. And
so
you help them.
Often we'll support teams, and it can be quite interesting because we'll wear different shirts as well. So we rebrand ourselves, so to speak, to be the technical support for some of these companies. Often it's manufacturers, often it's sites where we'll go in, we'll be the experts that cover that higher level stuff, or we deliver the training, or we create the maintenance procedures behind it all. There's the shirt, we like it. Wait. We're set now. We're a team now. We're a team. We love it.
It's just a bit big for me, Kyle.
Damn.
But it's all about being able to show up and be the part of the team, right?
Absolutely. Be a part of the team. Put the shirt on. Be a part of the team. Deliver to their customers, and be the solution, the total solution. Solve the problem. Solve the issue for your customer. Look really good in front of your own customers, and just be an extension of that team that we can help them out as well. So we do that for training. We do that for high level technical support. We do that for design as well. There's a lot of equipment manufacturers around that we're the design team for. We do all the design work, but for the end customer, all they see is I bought this equipment from so-and-so and it works.
It's almost like white labeling you, right?
It's white labeling, definitely.
Yeah, beautiful. And I think the key thing there is it's a win-win-win. So it's a win for the customer, it's a win for the supplier, and it's a win for you guys, really, because
everyone gets what they need.
Oh, I've just had a new question come through. Pop.
Ooh,
are you ready?
Cool. Oh, I'm on the spot now.
You're on the spot. There's no preparing. So Peter says, I'm looking to create a small-scale hydraulic braking system. I have trying to find a way to acute the master cylinder remotely through the control systems. Any recommendations?
Wow, that's a pretty good question, that one.
I'm going to pop it into the our chat box for you so you can see it as well, Kyle, in case I didn't articulate it correctly.
Ooh. So I'm going to take a bit of a guess on this, but Peter, by all means, shoot us a message with your email address, and we might go backwards and forwards a little bit on this one a bit more. So a hydraulic braking system, I'm thinking probably maybe a brake on maybe a slew or something that moves. So I'm thinking a mechanical brake. And so to actuate it remotely through a control system can be done a couple of different ways. We can just use simple cartridge valves and some electric control, or we can build it completely from a hydraulic control system if you can't have electrics in there. So there's a couple of different ways that it can be done. We can incorporate things like timing. So we can do the timing on that. We can delays, force control, or braking control, so that it's not an immediate hard braking, it's actually slowing it down. So there's a whole heap of complexities in it, but it's not super hard to do. It's certainly very, very doable. There's lots and lots of brake systems around that have just hydraulic controls in them. We've designed a couple using I spoke about counterbalance valves before, so using counterbalance valves and a motor to slow down a conveyor belt, just as one example of where we've used hydraulics as a brake, so to speak.
Awesome. So Peter, like we said, if you want, drop us a DM or your email address, and Kyle can diagnose that in either more detail, or the team will get on board with you and help you through that problem.
Cool.
Actually, even that link that we had before, he could book in, couldn't he?
Yep. Yeah, book in, shoot some info to us, and we'll try and help you out.
Amazing. Okay, cool. So I have another question for you. From John. John says, installed a set of valve banks on a system on first start. No hydraulic functions would operate, and the system was getting very hot.
Yeah, again, I have prepped for this one, and I did go backwards and forwards with John a little bit on it. So this is a really good story to tell, and it was actually a little bit interesting that this came up, because I'd just been talking to my team about this particular principle, so to speak. So putting valve banks on a machine, I understand that, and you put them on, and I guess the theory is that everything should just work for you straight away. And my initial thoughts were there was a blocked hose somewhere, or a crushed hose. There was maybe some hoses back to front, which would do it, or there was an incorrect setting in some valve somewhere that would basically open the relief valve, create a whole heap of heat in the system, and nothing would work, so to speak. So I know John sort of was probably setting me up a little bit on this, and that's a bit of fun. So he sort of said to me, give me a couple of ideas and then I'll give you what the real reason was. So I shot him back those ideas, and what he said to me was, yeah, it was the relief valve, but it wasn't any of those other things that you said.
Huh.
Yeah, that's curious. That's really, really curious. And what he told me was it was this principle, and I struggle to actually pronounce it, but Nikola Tesla actually used this principle.
Let me try. The Helmholtz effect.
I think that's it, Helmholtz.
You can blame me being blonde if it's wrong.
Now, I hadn't actually heard about this until probably last week. And so Nikola Tesla actually created a non-return valve using this principle. And I would strongly recommend that you look it up and look at how this works. So it's basically by pushing the flow of oil so that it works against itself, it actually stops itself because it gets too hard for it to actually work. So, and it's hard to picture it without the actual picture itself. But when you look at the picture itself, so the oil's basically being redirected back to itself, and it's fighting itself. And if you have a couple of these, it all stops. So what John said was that they had some T-pieces in the system and some 90-degree elbows. And this is fairly usual stuff that you might see in a system anyway. But in this particular configuration, what it was doing was blocking the flow completely. So inadvertently, we'd applied this principle, this Helmholtz principle, and stopped the flow from moving through the system, which then the relief valve's blowing, the system's overheating. So what a phenomenal thing to come across. And again, it's actually probably one of those one in a million things that you might come across to actually see it. And yeah, it's just amazing to find that stuff actually happening when we don't want it to.
Oh,
Sorry,
wow.
I got my nerd on a little bit there, didn't I? I got all excited about this physics principle and mind blown. But it's just phenomenal that it can happen.
And I say if you're doing these types of things all the time, like if your only thing is doing hydraulics and only thing is troubleshooting and designing things, you're gonna get to see the one in a million things a lot more than what your average person on site is gonna find, right?
Absolutely, it's pretty surprising how often we see them.
Yeah, and I think the other thing is because you've got such a big crew that's not only out there teaching but designing, troubleshooting, consulting. With you guys, it's not just like we're not just reliant on your brain for an answer. How many years has Dad got in the industry?
So Dad that works with us, he's been doing this for let's say 4 decades. I think we're actually past that now. So he's been doing hydraulic stuff for so long, and like I know this much, he knows this much, and the world is so much bigger than that as well. But yeah, it's really, really great to have certainly Al in our team that has 40 years experience on all these different machines. But then the rest of our team they've got 10 or 15 years experience on all different ranges of things. And it's not uncommon for us to be able to solve that problem as a team that really one person struggles with. And that's the fun of having a team like we've got, that we can brainstorm this crazy stuff and learn from it as much as anything else.
Yeah, you guys just crack out Taco Tuesday, sit around, geek out on the physics of the Helmholtz effect, and
that's it. We just get our nerd on and talk that stuff all the time. Yeah, absolutely. Although
I'm so sad that I can't travel there right now. I've been trying to come and get into the team and to be around when the brains are whiteboarding and finding all these solutions.
Absolutely. It is a lot of fun. We do try to have a bit of fun here. Nachos on the workbench out here was a lot of fun a few weeks ago, and there may have been a beer or two in that as well after work.
Well, see, I thought it should have been Taco Tuesday and tequila, but you said not safe.
Yeah, tequila might be a little bit too much. I don't like tequila.
I do believe that your copywriter may have had tequila for breakfast that day, though, because
I think we were talking about that because she did have a dare, I guess we could say, that she had to see out.
Yeah, a dare, a bet, a commitment, and
a commitment. That's it.
We're all about if you don't get what you're supposed to get done, or whatever. You got to take the punishment and the rewards.
Absolutely.
I would say that's probably something I do love about your team, Kyle. For me, having 13 years in headhunting and recruitment and working a lot with the industrial sector, working a lot with the actual manufacturers and different hydraulics companies, the industry can be a bit
boring.
A little bit boring, a little bit like in the like bumpered, little bit, straight and quiet when they're at work. We know they all get loose on Friday.
Absolutely.
But one thing I've definitely found that and this is across anything, if you're selling, if you're training, if you actually add a bit of fun and humor, then things stick a lot better. There's full science behind it. So what I do love is that your team...
Full science. Let's get the nerd on again.
Yeah, let's go nerdy. But I do love the fact that you guys are a great balance of nerd and fun. Yep. And that's what actually makes things memorable, and it makes it memorable for the team members and the clients that you're helping to be able to resonate with it and remember what's going on. So
to be nerdy about it, learning is an experience with a positive emotion will actually tie to a much better learning into the future and a much better retention. So an experience with a negative emotion and we forget about it quite quickly. So
did you learn that from Quick Super Brain?
Oh, actually no. No. So this is something that I actually researched this as I was doing my I think it's a graduate certificate in adult education. So I was doing a research project on
My brain
learning
goes somewhere else.
style.
Adult education. What now?
Adult education. So you know, it is something that I'm passionate about, and I was doing a research project on, and I had to present a document on how people learn and how to actually target that and get it really, really specific. And you know, to actually get a little bit more nerd on, there's actually a spiritual change that we all go through in our training as well, but that's getting quite left for everyone to think about. So not only do we have an experience and a hopefully a positive emotional response in all of that, but there's also a spiritual change that we all go through, which is quite a little bit out there, and you know, quite interesting for us to think about sometimes.
Well, actually, because you know I'm a little bit on the woo-woo side, I've been listening to The Buddha and the Badass. I'm getting through it, and just that reminder about we don't have a knowledge problem often. Like some of us have read some of this stuff. They may have done even the hydraulics training. They may have read the schematics books. They may have done it, but they have an implementation problem. And where the problem of doing from learning to doing is around the transformation. So there's got to be the link to the transformation, and the transformation comes in the action, but the memory link, like you said, that positive emotion that draws forward. So yeah, I love geeking out on the learning. And that's where the spiritual side comes in, when it actually transforms to your soul and it's making you move towards a destination that you want to get to.
Yep. Now, something that we probably shouldn't share too much with our engineering type guys. They probably don't want to think about that too much, but it is very, very true, and it is a part of what we do and why we do it. So, yeah, that it all comes into actually delivering a great training outcome. And as you said, it's the practice, it's the implementation. That's why, yeah, a lot of our students that come through, they're really, really clever. They've done some of this stuff forever, but they look at some of the, let's say, theoretical stuff, and it stumps them. And it just stumps them wholly and solely because it's outside that practice that they're always doing. You know, the technical bit, the hands-on bit they do all the time, but the theoretical bit gets a bit out there because they don't actually practice it.
Yeah. So I'm going to say to any of the engineering managers, any of the supervisors that are watching today, if you've got to instruct someone else on your team, I want you to, I'm challenging you, maybe you have to drink tequila if you don't do it now.
Ooh,
think about how you could make it more of an experience for the person that you're working with, a little bit more fun, so that they're more invested and they can have the transformation that you want them to have.
Yep. The way we teach people and the way people learn is exactly the same as the way people communicate and receive communication. And so it's just super important that we actually, yeah, I guess we'll digress a little bit more. You know, we talk about most of our students are tactile learners. They have to touch things. So it doesn't matter how much you actually talk to them, you're actually only talking at them. You actually need them to be touching things and understanding things, even if it's just, you know, they're just holding the valve. You know, the actual touching it has nothing to do with what you're telling them, but they're touching it and they can relate to it then. So
that's why we send out the little kids kits, right? With
absolutely, for the electric stuff.
Yeah.
Absolutely. I haven't got any close to me at the moment, but that's some of the fun that we get to have is the kits that we send out. And yeah, we can be big kids.
Yeah, I want my kit. All I've got is this bloody hose.
Oh, just this hose.
just this hose. I'm learning to handle it though. I just need to get some couplings.
It smiles though.
It's a massive smile. I need some couplings on the end. Yeah. Okay, well, beautiful. I think I've exhausted most of the questions for today. I know that we'll pop in the feed, there's some links there, but we'll make sure that they're added on as well for booking a free, must tell you guys, it's free, design consult with the APT team. If you want them to have a look over and help you troubleshoot designing something new, or you just want to like sanity check to make sure that you've done things right, the guys can jump on with you. The other thing is, if we haven't managed to get to your questions today or you have more questions, make sure you drop them in the comments. And we've got a team that will be keeping an eye on them, and Kyle can get back to you. I know he's, like you said, with John sent his question through early. He pinged back some messages just to help him get through the problem as well. So this isn't the end, guys. We're still here to help and support.
Definitely.
Anything else you'd like to share with the watchers today?
Just keep in touch with us. You know, any questions you've got, get them off to us. If we answer them on a video like this, or even if we shoot you a message back, happy to answer these questions. Yeah, for our team, it's a bit of fun sort of exploring what's going on and what issues people are having. So, yeah, we actually enjoy it. That's the part of it, is we actually enjoy what we're doing. So we're happy to answer those questions as they come through.
Awesome. What I've just done then as well, Kyle, is dropped a link on for the symbols book, our schematics basics. If there's people that are like, huh, all this stuff, what a schematic, huh? We've got that there for them as well. And there's also a link to our basic fluid power program, that if someone's just starting to dip their toe into this, and it's like these questions are just way far. Great place to start for less than a pint of craft beer a week.
Absolutely. So it's easy. You get our team, you get to talk to them each week. So yeah, again, those questions that you've got, you can ask them live with the guys on those calls, and yeah, get the answers to your problems.
Yeah, amazing. Well, thank you so much again for today. It was very beneficial to do a backup of the first live. I know that these questions were burning from Steve, Tom, Aaron, /Anon, and John.
Absolutely.
And guys, if you were watching along and you had a glitch in the technology, don't worry. Just send us a DM or your email address, and we'll get you the recording with all the sound.
With all the sound. Technology beat us, unfortunately. We'll have to look at what's going on there.
All good. Thank you so much. Have an amazing Thursday.
Thanks, everyone.